Hey everyone, and welcome back to The Explainer. Let's talk about time. It's kind of merciless, isn't it? Every moment just slips through our fingers, gone forever, becoming just a memory. And I think we've all felt it, that powerful, nagging wish to just go back. Maybe for you, it's about fixing something that just haunts you, a mistake you can't seem to shake. Or maybe it's simpler. Maybe it's just about getting one more moment with someone you miss, or reliving one of your happiest memories, just one more time. This dream, this urge to rewind the clock, it's something we all share, but it smashes head-on into a fundamental problem with how our universe is put together. Physics tells us that time and space are all part of the same thing, this single, unified fabric. But think about it. We can move any way we want in space, right? Forward, backward, left, right, up, down, no problem. But time? Time seems to be a one-way street. There's no stopping, no U-turns, and definitely no going in reverse. But what if we could bend those rules? Okay, so let's get into it, because our best shot at an answer comes from the guy who basically rewrote the rules on time itself, Albert Einstein. Now, his theory of general relativity, it sounds super complex, but it is the best map we have of how the universe works. In fact, it's so reliable that we literally use it every single day to make sure our GPS satellites work correctly. It tells us that space and time have to bend and warp around massive objects. But here is the absolutely wild part. For all the rules general relativity lays down, there is nothing, absolutely nothing in Einstein's equations that explicitly forbids traveling backward in time. And that single, tiny omission, that's the biggest glimmer of hope for any would-be time traveler. So, okay, if the math allows for it, how would we actually do it? Well, physicists have cooked up some seriously wild ideas, but probably the most famous, most plausible one is straight out of science fiction, the wormhole. A wormhole is basically a tunnel through the fabric of space-time. And here's the trick, the part that's so mind-bending. If you can build a wormhole, you've also built a time machine. See, relativity says time slows down when you move really fast. So if you take one end of the wormhole and zip it around space near the speed of light, time will take by slower for that end. Step through it, and you'd pop out in the past. But yeah, there's a catch. And oh boy, it's a big one. To keep that wormhole tunnel from just collapsing on itself, you need a ton of something called negative energy to prop it open. The problem? We have absolutely no idea if negative energy can actually exist on that scale, let alone how we'd go about making it. For now, it's completely theoretical. But let's just pretend for a second. Let's say we solve the energy problem. We still face a much, much bigger hurdle. And this one doesn't come from physics. It comes from pure, cold logic. You see, going back in time cracks open a whole Pandora's box of paradoxes. These are logical contradictions that could unravel the entire cause and effect nature of reality. It's like writing a computer program that's designed to delete its own code before it can run. It's the ultimate crash. And this really boils down to two huge brain-breaking problems. First, you've got the classic grandfather paradox. You go back, you prevent your own birth, but then how could you have gone back in the first place? And second is the weirder causal loop, where something just gets stuck in time with no real beginning. This example from the movie Somewhere in Time just nails it. The watch was never manufactured. It just exists, passed back and forth in a time loop forever. And the same thing could happen with information. What if you gave Beethoven all of his symphonies before he wrote them? He copies them down, becomes a legend, and then you take those copies back in time to give to him. So who actually composed the music? It's a total mind-bender. For a physicist, a paradox like that is just, well, it's not okay. It means the logic is broken. The universe has to make sense, right? So does it have a way to protect itself? Is there some kind of physical law that stops these logical nightmares from ever happening? To figure this out, scientists did what they do best. They simplified the problem. They took all the messy, unpredictable stuff like human free will completely out of the equation. They boiled the grandfather paradox down to its most basic mechanical form. So here's the setup, which came from physicists at Caltech. Imagine a billiard ball rolling toward a wormhole. It's on a perfect path to go in, emerge in the past, and collide with its younger self, knocking it away from the wormhole entrance. If it gets knocked away, it never goes in. It's a perfect grandfather paradox, just with a ball instead of a person. But, and this is where it gets so incredibly cool, the Caltech team found this beautiful, self-consistent solution. In this scenario, the older ball emerges and gives its younger self just a tiny nudge, a glancing blow. That little tap doesn't prevent the younger ball from entering the wormhole. It's the reason the ball enters at the precise angle needed to travel back and deliver that exact same grazing blow. The paradox just solves itself. It becomes a perfect, logical, consistent loop. No history is ever changed.
Okay, so that's a really neat solution for billiard balls. But what about, well, everything else? For a more universal answer, we have to turn to the late, great Stephen Hawking and his chronology protection conjecture. Hawking basically argued that the universe has its own built-in security system. The very moment you try to use a wormhole as a time machine, even a single particle of light looping through it would create an infinite feedback loop of energy. That energy would cause the wormhole to instantly collapse. In other words, the laws of physics themselves step in to protect causality. So where does all this leave us? Well, Hawking's idea is still the most widely accepted one, and its implication is pretty profound. Our dream of changing the past is likely just that, a dream. We can't go back and fix our mistakes. We can't save the people we've lost. We can't relive those perfect days from our youth. And yeah, that can feel like a real disappointment. But there is another way to look at it. The fact that we have to live with our past, that we can't just hit an undo button, that's what forces us to learn from it. It's what pushes us to look forward, to try and choose a better tomorrow. It makes us realize how precious every single day is, because it only happens once. This is it. Our lives have to be lived with a little bit of urgency. So maybe time's one-way nature isn't a prison. Maybe it's a gift that compels us to make the most of the days we have left. So the question it leaves us with is a really personal one. Knowing you can't go back, that this is your one and only journey forward, what are you going to do with the time you have?